All righty, so this is the second library series on linear functions. So we'll go over some pretty basic questions that you definitely want to know how to do, so you can move up the ladder. So this is called the standard form of a line. A graphing form is a way that a function is written so that you don't have to change the way it's written. You just graph from the perspective it's given. So if I ask you to sketch this line, then I expect it to be graphed from this perspective it's given. Otherwise, you haven't learned that this is a graphing form. All right, so time for a little concept. Products, something times something. Okay. Now, this is the first time in this series that we're talking about it. There is a something times something that's shall we say, how do I want to describe it? Well, let's do an example. I'll have you multiply this out. 9.738542 times 3.9995. Do you know the answer? I sure don't. Okay, that was a difficult product. Let me try it again. There's a couple of different numbers here. 9.3789521847649 times 0. That's 0. Okay. So yeah, if you see a product, and I got news for you, 3x, we call it a term, but it's a product. It's something. In this case, the number 3 times something. In this case, a variable. As in, let that number be anything you want. And if that's the case, given the example I just gave you, I think it makes sense to make this 0. And if you do, if you let that x equal 0, then it's like covering up this term. And I think that's a pretty easy equation to solve. And that's 1 point on a line, 0, 6. It happens to be the y-intercept. And this, I lost my 3x with that 0. And that is a product. Put a little dot between it. And if you do the same thing, it's like covering it up. Then 3 goes into 30 10 times. It's a little bit longer distance. And it looks to me as though we have an x and a y-intercept. And if you have 2 points, and you know it's linear, biggest operation is one-dimensional here. You got yourself a problem in your back pocket. And so we'll make sure it's in your back pocket by asking you to sketch or to name the 2 points that are involved in that standard form equation. All right. So 5x plus 2y. Well, I think we did addition last time. Let's do subtraction. 5x minus 2y equals 20. Pause the video. I'll just keep going. Cover it up, -10. We'll call that 0, -10. And you'll find that this is increasing when it's a subtraction. I did that one, so we'll do this one. 4. Equation of the line is done. Let's do another one. This time we'll do some fractions. Let's do 3x plus 4y equals 17. This will be a decreasing function. X and y's, cover up the y's, 17 thirds, a little less than 6. 17, oops, because I'm going down, put it on this side. 17 thirds gets me the no altitude x-intercept. And 17 divided by 4 is a little more than 4. It's a little shorter distance. And we get 0 for x. 0 is the y-axis, x equals 0 is that line, and y equals 0 is the x-axis. What did I say? 0 for x, 17 over 4. I think enough said. Okay, you already should know how to do that anyway. All right, so let's move on down the line. Let's talk about parallels and perpendiculars. First thing we have to do is see a perpendicular to a line. So let's talk about an input-output. Let's go 2 marker lengths to the right. That's change in x of 2. Go up 1. Okay, and I think that dotted line has what we call a slope m of 1/2. I'd like to call it a of 1/2, the adjuster. All right, and let's actually draw a perpendicular. Since I'm doing this, I should try to do it properly. So let me get a piece of paper. I have a feeling that the manufacturer has a nice 90-degree angle here. We'll do it right from there. All right, that's pretty good. And let's actually measure the slope and see what it is. Should I call it the conversion ratio? I have a feeling if I go over 1, better look, that's over 1, which is the x. And now coming down, I think, geez, that's 2 marker lengths, but I'm going down 2. That's the new slope. Huh. If we know the old slope, I think there's a way, looks like a pattern there. Yep, negative reciprocal. So we have to be able to find the original slope of that line. All right. And the slope that you're all so familiar with all across the country, y equals mx plus b, can be found, because that's supposed to be the y-intercept, right? Can be found by finding the multiplier in front of x when isolating the y. So I guess we're going to solve this equation for y, and I don't think this constant, that's a constant, it's going to have much play here. So I'm really looking at 2x equals 5y, and I'm looking at y coming from 2/5 of whatever my input is. Well, there's your slope. So it looks like your perpendicular slope is minus 5/2. And so I'm writing a new, and I got to multiply that times x, but I want it to go through 4, 7. So from our earlier work, I hope that makes sense from the first video. And it's always good to erase the intermediate work when you're on a blackboard or a whiteboard. Kind of look and go, okay, well, there's the original question, and my answer is minus 5/2 x minus 4 plus 7. Because sometimes you can look at something and go, you know, I don't even have to do any work. I can just get this answer. But you try to figure that out, because math is all about patterns. So you keep an eye out and see if you see any patterns here. Okay, so let's change this up now. Let's go with 4x plus 7y equals 23. And let's have it go through, how about negative 620? I guess that x plus 6 plus 20 is going to be part of this. And all I got to do is find the slope. And I think I'll do parallel and perpendicular. X plus 6 plus 20. Parallel lines, right, have the same slope. Over, up, same, right? So parallel lines, we just have to get the original slope. So let's do parallel, and perpendicular. All right. So it looks like 4x. Oh, I always like to divide by a positive. So I'll leave 7y on this side, and I'll move the minus 4x to that side. This doesn't matter. So y is equal to minus 4/7 is the original slope. So the parallel slope is the same as the original slope. And the perpendicular is the negative reciprocal. In this case, the opposite of the negative is a positive. And you switch your x's and your y's. Your change. All right, let's do one more. Parallel perpendicular. Not much I can do to standard form to change this up. I mean, there's a couple of special cases, x equals y. Let's just go with the fundamentals. Let's go with 3x minus 20y equals 43. Okay. All right, I don't like dividing by a negative. So I don't care about the constant. So 3x equals 20y. So 3/20 is the original slope. So how about we get it to go through, hi there. Let's have it go through hi there. So parallel is the same slope. So that would be y equals 3/20 x minus high. You tell me, you say high. I'll say there. That's parallel. Perpendicular now is going to be the negative reciprocal. Side plus there. Guess we're done with that one. All right, so let's move on down to systems of equations. All right, now, I like the elimination method. More students, I think, are taught the substitution method coming into my classroom these days. So let's just mess around with the elimination method. All right, I already got a canned one. We already know the answer is 1, 2, because I made it up that way. 5 times 1 is 5, minus 6, 5 minus 6, -1. If x is 1 and y is 2, 14 and 1 make 15. So the question is, how do we solve that? And we want the x and the y. And I hope you're recognizing standard form. We just graphed it a second ago. So that's a line that's going up with x-intercepts at what, 1/3 is the y-intercept. We'll call that 1/3. -1/5 is the x. That's even smaller. So we got a kind of a line that's passing through there. X is 15 for an x-intercept. That's 1/3. I've got 15 is way out here. And near 2, right? Near 2 for a y-intercept. If that's 1/3, 2's here. All right, so my intersection is looking to be about, 1, 2. Yeah. Guess I knew that. All right. So it's always good to have a little feel for the graphs. Now, I think most textbooks talk about subtraction, the columns. So I better talk about the columns here. So if we have 1 plus 2, we know that's equal to 3. If I multiply everything by 10, I get 10 plus 20 equals 30, which is still true. So I guess I can multiply every single number by something that not going to change the equality. As long as I multiply it by the same number, it doesn't change the equality. So that's one principle that needs to be understood about the numbers in this situation. And if I add up columns, 1 plus 2 equals 3, and 4 plus 5 equals 9. If I add up the columns, I get 5 plus 7 equals 12. That appears to be true too. Okay, but it's pretty hard to solve. X plus 7y equals 15. You add up the columns right now, you get 6x plus 4y equals 14. That doesn't help me too much because there's an infinite number of solutions. There's a lot, 1, 2 is just one of them. 1, 6, and 8, 14. I mean, that's true, but so many other situations are true that doesn't help me. Be nice if one of the columns is gone. And I find that subtracting, I find actually this is the one time when adding an opposite is easier than subtraction. I mean, we, try to break students of the habit of writing plus, some people do -6, stuff like that. I don't know. I forget exactly what you see. Maybe it's in parentheses. We just, can't you just say subtract 6? Right? But in this case, adding opposites is very helpful. Just a little bit easier. So if I'm going to get rid of a column here, I think I want to multiply this one. And I hope you can see why I want to multiply it by -5. So if I do, I get the top. I haven't moved. Top's the same, but I'm going to multiply this by -5 this time. And I wouldn't do this to the original if I was on paper. I'm doing it here because I got an eraser. Okay, so I can play with it, come back and erase a few things. But you should leave originals alone and rewrite left and right side. Maybe I'll do that on the next one. Leave it alone and be a better role model here. -5x -35y. I got to be careful because if I make a single mistake, it's going to be hard to find it. -75. There we go. That cancels. Next time, maybe I don't even write that part. I got -38y is equal to -74. That tells me my y value is 2. And so then I could just say x plus 14, plug in the 2 to y for a situation like this. this, right? I can see my X value is 1, right? And then you write your answer 1, 2, point of intersection. All right, whoops. Okay, erase that mark on the board. Got it. And if I wanted to get rid of, I'll do this time. Let's say I'll leave the X column alone and I'll play with the Y column this time. And if I'm going to do that, then I got to do 2 multiplications. 5x minus 3y equals -1. And I got to do x plus 7y equals 15. So I got to multiply this one by 7 and this one by 3 because I still want the opposites. Right? So that's going to be minus 21, positive 21. I don't even have to write this column, but I got 35x equals 7 times -1, -7. And I got 3x. Here's my 38 again. 45. When I add those up, I get 38x equals 38. There's my x equals 1. Okay, so that's the elimination method. I don't think we're gonna, it's just tedious work. It's an awful lot of, there's probably 3, 6, 7, 8, 9, 10. There's like 12, maybe 12 things you got to do. Anytime you got to do that many tedious calculations, computations, easy to make a mistake. All right, so let's do something where we don't have such a nice answer. Let's do 2x minus 3y equals 14. And let's do 5x plus y equals 8. I hope you choose to multiply by a number that cancels this column, be easier. All right, so let's do that. We're going to get rid of the y's. So therefore, I'm solving for x. So I'm going to put that on this side. And I'm going to leave the top one alone. Oh, I forgot to get a graphical, but I'll multiply this one by 3. 15x plus 3y equals 20. All right, but let's get a feel for what our answer should be. So y-intercept near -3, 4-ish. So we'll call that in between 3 and 4. 7 on the x side. Okay, that to me is about twice that. This one is 8. Well, that's nice. That was 4. 8's up here. Ooh, I'll put it right there. I should have done a better job with this. And the x is a little bit bigger than 1. So that'd be here. So we get a line that's doing that. Get a line that's doing that. Looks like I have a pretty small x value and a slightly larger magnitude negative on the y. So something like, we said that was a little bit bigger than 1. So maybe near 2-ish. And this is near -3-ish. Okay, so I'll just keep that in the back of the old noggin. And let's hope I didn't make a mistake. It's actually the second video I'm doing today. And it's mid-afternoon. That's my nap time. I shouldn't be doing this now. Oh, back over here. 17x is equal to 34, 38. A little bit bigger than 2. 38, 17. So I said we'd be near 2. So I like that. And let's come over here and do the y. So it's 38, 17 is the x value where these two linear functions intersect. And let's do the, what am I solving for? Y's now. So therefore I got to get rid of the x's. So I've got 2x minus 3y equals 4. I could substitute that in, but I don't want to work with fractions right now. We have 5x plus y equals 8. I'll take a little shortcut. I'll multiply this one by -5, this one by 2. I'm not going to do the x's. I can see they cancel. So that's 15y equals minus 70. And this one is 2y equals 16. I'll add it up. Looks like minus 54, I believe. And this is 17. 17y. And that's minus 54 over 17. Which is pretty close to -3. That's what we were hoping for. So that's what you'd have. I can do more of these, but we're going to do them all semester, all the worksheets. I think you'll see some of those, but they're online all over the place. The only thing is, a lot of times you'll see that instead of multiplying the negative and adding, people just get the same number and then subtract, but you got to remember to subtract each part. One more layer of potential difficulty. I like to eliminate difficulties. All right, so that's systems of equations. Theoretically, you've already done it and you have it mastered, but I'm finding that's not the case. All right, so here we go. We already established that if we multiply everything by the same number, we're still equal. It would sure be nice to get rid of division by 3 and division by 2. And we talked already about, I think in the first video, 8 fourths into 12, things like that. That you could do 4 into 12, which is 3 times 8, which is 24. You could do 8 times 12, which is 96 divided by 4, which is 24, right? So you could start anywhere you want, right? And you could go in the other direction, right? You're gonna get the same answer, but it's either multiply and divide, or divide then multiply, or divide then multiply in that direction. So I am gonna multiply by 6 up here, which means I can do that and then divide, or I can divide and then multiply. So I'm gonna go small, then big. 3 and a 6 is 2, times 7x is 14x. 6 times minus 4 minus 24. 2 and a 6, 3. 3 times 5x is 15x. And 6 times minus 1 minus 6. I don't like dividing by negatives, so I'm going to move the 14. I'm going to subtract 14x, which allows me to immediately get my answer. And so my x value is adding 6 to this is minus 18. And you can do that in your head. And you should start practicing that. And I certainly don't want to see plus 6 plus 6. I don't want to see that. And you're not going to go up the ladder doing that. I don't think. Although you see good mathematicians doing it on YouTube all the time. But I do think that you're going to benefit more from thinking in terms of inverses than the scales of justice. We know where those are right now. All right. So let's go back to the original. 7x over 3 minus 4. I forgot what my answer was already. I think it was minus 18. We'll keep that in abeyance. So this is a line, y-intercept negative 4. We'll call that minus 4 over 3 up 7, something like that. This is a line, minus 1, and over 2 up 5, over 2 up 5, maybe here. So I think, boy, this is one that's a little tricky. I got a feeling my intersection's down here. Well, no, it was an x value, negative 18. I'm nowhere near. What did I did something, did I do something? That's why I'm doing this, because sometimes if your graphical analysis doesn't match up, you gotta go back and look at your work. 2, 14 looks good, minus 24 looks good. 3, 15 looks good, minus 6 looks good, adding 6, minus 18, x equals 18. Whoa, so let's do a better job of graphing. So, negative 4, let's actually go right there to the fingers. That'll be, well, let's call that negative 4. All right, 1 marker length. It's pretty close. All right, so I'm going to go over 3. 1, 2, 3. Boy, be easier to plug the number in and see if it worked. Maybe that's what I should do here, because it is the afternoon. It is nap time. All right, minus 1. I'm going to definitely sketch here minus 1. And over 2 up 5. This is, let's call this a 2 to 5 ratio. So that's 2. Making that 2. It's 1, 2, 5, right about there. Okay, so that's that. And this one was here. Well, they're almost kind of parallel, huh? So I guess this one's coming more this way, and it's going to take a long time for those to intersect over here. That's what I guess is happening. And I'll put minus 18 in because it looks like it's pretty easy to work with. So let's drop minus 18 in. 3 into minus 18, minus 6, minus 42, minus 4, minus 46. Let's drop negative 18 in here. Minus 9, minus 45, minus 1. Definitely works. So it was a tricky graph because those slopes were too close together. Let's get something this time that makes that disappear and eliminate that problem from the graphical perspective.
let's look at 5/4 x minus 3 is equal to negative 7/2. No, I don't want to do 2. Let's do a 3. 7/3 plus 4. Okay, up, it's got my x. Yeah, definitely am getting tired. All right, so maybe this will be the last one we do. So you pause the video, right? I hope you're multiplying by 12. So that's going to be 5x is going to become 3 times bigger. That's going to become 12 times bigger. That's going to become 4 times bigger. That's going to be 48. Okay, I'm going to move that this way. I don't like to divide by a negative. 28 and 15, 28 and 15. Oh, my brain isn't so 38, 43x. Adding 36 to 48 is 78 and 6, 78 and 6, 84. So this is near 2, x equals 2, 84 over 43. And so let's just do a graphical. I don't want to plug that in. So let's do a graphical here real quick. We get the 12s. We got a negative 3. We'll call that minus 3 units. Over 4, up 5. Okay, and this one is up 4, which is going to be a little higher. Over 3, down 7. Over 3, down 7. Boom. I really missed that. Boom. Boom. But is my x near 2? Yeah, it's a small x value and it's positive. Yeah, good enough for me. All right, yeah, I am going to go find my couch. All right, so that we're adding that to our fundamentals, linear fundamentals. I don't know how many more fundamentals we're going to cover in a linear because we got to get to exponentials, logarithms, sinusoid, all kinds of good stuff. Right, and this one.